Precalculus Lesson 20 is applications of exponential and logarithmic functions. We begin with compound interest, for which we will have two different formulas. This is section 4.5 in the college algebra textbook. Let's get started with the compound interest formula. A equals P times 1 plus R over N raised to the NT, where P is the principal amount of dollars that are invested in an account earning interest at an annual rate R. Here we'll need to make sure that R is in decimal format before plugging it into our formula. Interest is compounded N times per year, and then the amount A is the amount that we will have in this account after T years. If Ted invests $5,000 in a CD at an annual interest rate of 3.45%, compounded quarterly, we're going to figure out how much Ted will have in his CD at the end of 5 years. In this first example, we have A equals P times 1 plus R over N raised to the NT. And let's see, if he invests $5,000, that's going to be the principal. An interest rate of 3.45% tells me that R here will be equal to 0.0345. Then compounded quarterly, 4 times a year, we have N equals 4. And we're looking at how much Ted will have at the end of 5 years. So right here, our 5 years is going to be our T value for this problem. Plugging in these numbers, we have A equals 5,000 times 1 plus 0.0345 divided by 4, all raised to the power of 4 times 5. Simplifying, we get 5,000 times 1.008625 raised to the power 20. Noting that I would not simplify at this point if 1 plus 0.0345 divided by 4 was not exactly 1.008625. Otherwise, I wait until the end of a problem to round, because I want as an exact value as I can get. I don't want any rounding errors along the way. So let's plug this in a calculator, and we get 5,936.97 as our rounded value. So Ted will have $5,936.97 in his CD at the end of 5 years. Note that banks might round a little bit differently, so he might only have 96 cents rather than 97 cents, depending on how banks would round here. How much will you need to set aside from your $4,500 tax refund to have $4,000 for a dream cruise 3 years from now? The bonds you are planning to invest in have an annual interest rate of 9.7% compounded semi-annually. So let's use this information to plug in for A equals P times 1 plus R over N raised to the NT. And first of all, this time, we're trying to solve for P. We want to know how much we want to start with in our account rather than how much we end up with. In fact, we want to end up with an amount of 4,000, so that's going to be our A here. Our interest rate here is 9.7%, which we will write as 0.097. And then we have N, the number of times interest is compounded per year. Semi-annually means twice a year, so N equals 2. And what else am I missing? T, the number of years, would be 3. Okay, so let's plug all these numbers in, and we get 4,000 equals P times 1 plus 0.097 divided by 2 raised to the power of 2 times 3. We simplify just a bit. We write 1 plus 0.097 over 2 as 1.0485. We write 2 times 3 as 6. And note, we're solving for P here. So the next thing I'm going to do is to divide both sides of the equation by 1.0485 raised to the power of 6. I'll plug 4,000 over 1.0485 raised to the power of 6 into my calculator to get approximately $3,010.57 as the amount that must be invested now to have $4,000 in 3 years. And note, you could just as easily stick $4,000 in a drawer somewhere. Why would it be advantageous to invest your money Well, think of how much more you would have to spend now from that $4,500. Rather than just having $500, you would actually have $1,489.43 to spend now if you only had to invest $3,010.57 at this point in time. Okay, continuously compounded interest. We use the formula A equals P times E raised to the RT. If you think of shampoo, there used to be a kind of shampoo called Pert shampoo. It's actually around some places as of today. I think I saw Pert shampoo when I was in Hawaii, so it does still exist. But continuously compounded interest uses the same principle, letter P. So we use P for our principal amount of money that is invested. We're still earning interest at a rate R. And now interest compounded continuously, that means that rather than say 4 times a year or something, interest is compounded every fraction of every second of every day. And then we're looking at the amount that we have after T years. So let's do a problem here. And we're going back to Ted again. And Ted's CD now is compounding continuously at the annual interest rate of 3.45%. We want to know what will be the result of his investment of $5,000 at the end of 5 years. So we have interest rate 0.0345. We have T equals 5, and we have P equals 5,000. Plugging these numbers in to what is a bit of a simpler formula, we have A equals 5,000 times E raised to the power of 0.0345 times 5. Multiplying 0.0345 times 5, we get 0.1725. And now we're just going to plug into our calculator 5,000 times E raised to the 0.1725. to get an amount of $5,941.36 that Ted will have in his CD. Okay, so one note here, while you're working through this lesson, use your own calculator to try to plug in the values in our formula. Make sure you can use your own calculator to get these same numbers that I'm coming up with. And one note here, when we compounded Ted's interest quarterly, we would have had $5,936.97 after 5 years. Here there's a tiny bit more, but not significantly so. Okay, what if Ted's CD compounds continuously at the annual interest rate of 3.45%? This time we want to know how long it will take for his investment of $5,000 to double. So same formula, A equals P times E raised to the RT. But now, well, if we start with an amount P of 5,000, we're looking for when that amount doubles to become an amount A of 10,000, and we still have 0.0345 as our interest rate. We're trying to solve for T here. So we'll do this a little bit different, but this should be good practice for what we have coming up shortly. First of all, I'll divide both sides of my equation by 5,000, and I will note that 10,000 divided by 5,000 is equal to 2. From here, I want to pull that exponent of 0.0345t down so I can solve for t. So the next step here is to take the natural log of each side. We have natural log of 2 equals the natural log of e raised to the power of 0.0345t. Natural log of e raised to the power of 0.0345t is simply 0.0345t, from which step I will divide both sides of my equation by 0.0345 to get t equals the natural log of 2 divided by 0.0345. Plugging in a calculator, t is approximately equal to 20.0912. As an answer to this problem, I would say it will take Ted's investment approximately 20 years to double. If we were asked to give a more accurate answer, we might say approximately 20.1 years or 20.09 years. Try on your own. Number 1 is to determine how long it will take for an investment of $1,000 to double at an interest rate of 4.3% compounded quarterly.